Hi, this is Physics 2212, Lab 1. Here's an overview of the lab. The purpose of the lab is to explore electrostatic and gravitational forces. Introduction. Fundamental physics principles used in this lab are gravitational forces and electrostatic force. Some important values for this lab are the length of tape being 20 centimeters and the mass of the tape being 0.0002 kilograms. Gravitation can be simplified to F equals ma for close-to-Earth surface calculations, which is the case in this lab. In part 1, the negative or the neutral objects used were books, and for part 2, two tapes repelled each other, and the net force on tape in the y direction was 0. The final was calculated from measurements taken from floating one charged tape over another. Note the assumptions that were made for code and calculations at the bottom right of the slide. On the left, we have the point charge model, and on the right, we have the line charge model. White is the electrostatic force vector, yellow is the gravitational force vector, blue is bottom tape, red is top tape, and green is the electric vector field. Note the values printed under the visualizations. Force Model 1 uses the equation for electrostatic force and gravitational force given earlier to calculate all forces on the object and the electric field and visualize them. Model 2 uses the previous code in addition to new code in order to run the same simulation, but this time it treats the charges as a line charge as opposed to a point charge as the first one did. The what-if question is, what if electrons are negatively charged and protons are positively charged? What if the signs of their charges were reversed? Meaning, if electrons were positive and protons were negative. What would change about the observations you made with your tapes and other charged objects? My answer to this question is that if charges of protons and electrons swapped, it would swap the directions of the electric fields and electric dipole moments, but overall, the forces would be the same, i.e. opposites attract and like charges repel. Therefore, all observations would effectively be the same. Here's another question. Compare the estimated value of the charge you get when you use your experimental data to produce a point charge model, which is the first code, to the value you got with the line charge model, which is the second code. The two computational values for Q, the point charge model versus line charge model, will be different. Why are they different? Which value is more likely to be closer to the real value? Why? The point charge simulation found the charges to be 1.777333 times 10 to the negative 8 coulombs, while the line charge simulation found it to be 1.96436 times 10 to the negative 3 coulombs. The line charge simulation should be closer to the true value, as in reality, the charge is spread across the entire surface by the tape, which I calculated to be roughly 380 million atoms. Fun fact, the charge was calculated to be spread over 380 million atoms. This means that because there were roughly 62.29 billion excess electrons, each atom had to give up about 1.64 electrons during polarization. Bye-bye!